Good evening to one and all gathered here. I'm Dr. Sumithra, Professor, Department of Electronics and Communication, JJ College of Engineering and Technology. Here, I'm going to deliver about mechatronics. So what is mechatronics? So what are the emerging areas of mechatronics? Actually, mechatronics is a dynamic interdisciplinary field combining mechanics, electronics, computing, and control engineering. It was globally recognized the value worth 130 billion US dollar in 2023, and it drives innovation across manufacturing, healthcare, and more. And in India, it is rapidly increasing its participation in global R&D and adoption of mechatronic systems, positioning itself as a key player for future technology. So next, how you understand about mechatronics? Actually, mechatronics synergizes mechanical, electrical, computer science, and control engineering to create intelligent automated system. These technologies are integral to product ranging from anti-lock braking systems in vehicles to advanced industrial robots. The focus is increasingly on developing smart products with enhanced autonomy functionality. What are the key drivers of new frontiers in mechatronics? AI and machine learning. It enables predictive maintenance and intelligent system decision making to enhance reliability. Next, IoT and sensors. It allows real-time data collection and seamless connectivity for smarter automation. Then advanced materials improve component durability, performance, and reduce maintenance. Computational power, it supports complex simulations and sophisticated control algorithms for smarter systems. Miniaturization facilitates development of micro robots and implantable device with precise functions. So next, coming to the advanced manufacturing in mechatronics and industry 4.0. Integration of cyber physical systems, IoT, and AI transforms factory into smart production systems. Additive manufacturing enables creation of complex custom parts. Predictive maintenance cuts overall downtime up to 30%. Tata Steel's Jamshedpur plants exemplifies AI-driven mechatronics for superior quality control, setting benchmarks for industrial advancement. Then coming to bio in mechatronics and healthcare. So mechatronics had wide applications in bio and healthcare industry. So biomechatronics merges robotics with biology to revolutionize healthcare. AI-powered bionic prosthetics offer functionality with neural control. Surgical robots like Da Vinci systems enhance precision by 50%. Wearable smart sensor continuously monitor vital signs, exoskeletals, and rehabilitations. India is innovating low-cost robot surgery platform to widen healthcare access. Then coming to the addressing modes. So here, how to understand about the addressing modes. So here, addressing modes specify how the CPU interprets or modifies the address part of the instruction, enhancing flexibility and optimizing memory access patterns. So what are the impact on performance? They directly influence program performance, memory utilization, and instruction set complexity, enabling diverse data access methods like constants, variables, array elements, and stack data. Then register indirect addressing modes. So here in addressing modes, we have direct addressing modes and indirect addressing modes. In that, just an example, what is a register indirect addressing? So register as a pointer. Here in this register, we are using register as a pointer, and CPU register holds the effective memory address of the operand. Then dynamic access facilitates dynamic memory allocation, pointer implementation like move x, dx. Data structural transversal enables efficient transversal of data structures such as linked list. So addressing modes plays a major backbone of computation. So here it improves adaptability, efficiency, evaluation, and foundation. So coming to adaptability, here diverse methods for data location. Efficiency, it optimizes CPU operation and software execution. Evaluation adapts with advanced architectures for performance and flexibility. Foundation for system design and low-level programming. So next one is ADC and DAC, analog to digital converter and digital to analog converter interface. So here it bridges analog and digital worlds. In real of modern electronics, ADC and DAC are indispensable. They serve as a critical link enabling communication between the continuous real-world analog signals and discrete digital data processed by computers. Their fundamental role spans diverse fields from IoT to sophisticated multimedia systems and precision industrial automation. So how we understand ADC and DAC? ADC is nothing but it translates continuous physical signals such as voltage or current into a discrete digital numbers. This process is vital for sensors and input devices to feed data into digital systems. The next, digital to analog converters value back into continuous analog signal. It enables digital systems to control real world phenomena like sound output or motor movements. Then working principles of ADC. So first one is sampling. Sampling is nothing but the analog signal amplitude is captured at regular intervals. The Nyquist criterion dictates the sampling rate must be at least twice the highest frequency component of the signal to prevent data loss. Next one is quantization. The sampled values are approximated into the nearest discrete digital level based on ADC's resolution. For instance, 8-bit ADC provide 256 distinct level. The next one is encoding. Each quantized level is assigned a unique binary code. So common ADC architecture include successive approximation, sigma delta, and flash ADCs. The next one is a data handling. So here data handling in today's digital economy, effective data handling is a paramount for business to thrive. It underpins informed decision making and fosters operational excellence. India's rapid digital transformation is generating an unprecedented volume of data, making robust data handling capabilities essential. Major challenges in data handling. What are the challenges in data handling? First one is data quality. Next one is data volume and velocity. Then regulatory compliance. So in quality, incomplete or inconsistent data can lead to a flawed insights or poor business decision. So poor data quality is estimated to the cost between 15 to 25% of the revenue annually, highlighting the need for a rigorous data validation. The next one is data volume and velocity. Managing petabytes of data flowing in real-time presents a significant challenge. With India's internet user projected to reach 900 million by 2025. The sheer scale and speed of data generation demands sophisticated handling solutions. Next one is regulatory compliance. Adhering to evolving data privacy laws is a complex task. India's Digital Personal Protection Data Protection Bill 2023 mandates strict personal data protection, requiring business to implement robust compliance framework to avoid penalties. Data as a strategic asset. Effective data handling is no longer just an operational necessity. It is a strategic imperative. By transforming a raw information into actionable intelligence, business can drive sustainable growth and ensure regulatory compliance. The future of the business success fundamentally hinges on mastering the art and science of data. Then coming to the types of stepper motor and servo motor. So how to unlock stepper and servo motor? So the world of stepper and servo motor is very critical for modern automation and motion control. The global industrial motion control market reaches 16.5 million USD in 2023, highlighting their importance in robotics, manufacturing, and consumer electronics. These motors achieve unparalleled positional control. Then, so which motor we have to choose? So which one is the right motor? So stepper motor or servo motor? So here are the key points of stepper and servo motor. So here it is having open loop control and it follows inherent steps. Here in servo motor, it follows closed loop and continuous feedback. Coming to accuracy, it is step-based, no error correction. Here coming to accuracy, it is high precision, active error correction. Cost, lower initial cost, simpler to drive. Here it cost high, very high, and it is very complex drive. Then coming to speed, it is having high holding torque drops at speed. Here servo motor is having high torque at all speeds and it is dynamic. So coming to servo motor, here we have DC servo motor, AC servo motor. In DC servo motor, we have brushed DC servo motor and brushless DC servo motor. In brushed DC servo motor, it is very simplest, low cost, and it is ideal for application below 1 kilowatts, such as small robotic arms. Brushless servo motor, it is having high efficiency, longer lifespan, suited for higher speeds and robust application like medical equipment. Coming to AC servo motor, it is having two AC servo motors, synchronous AC servo motor and asynchronous AC servo motor. In synchronous AC servo motor, most common high power density and it is very dynamic response to 100 kilowatts found in industrial robot. In asynchronous, it is robust, good for high inertial loads used in large industrial presses and material handling system. Conclusion. Mechatronics is a rapidly evolving with emerging areas like AI integration, IoT-based automation, advanced robotics, driving innovation across industries. Understanding addressing mode is crucial for efficient microcontroller programming and data manipulation. ADC and DAC interfaces serve as a critical bridge between analog signals and digital signals, enabling accurate processing. Effective data handling ensure reliable system performance and communication. The selection and application of stepper and servo motor, each with unique control capabilities, are vital in precision motion control. So with this, I am just concluding the emerging areas of mechatronics. Please do write your comment and feedback on smithras@jjcet.ac.in. Thanks for your patience. Thank you.